Okay, so I created a TCP IP client host solution, and it's very simple, and it depicts sending prepared objects through a network. And it's using an open-ended buffer, which is not recommended with TCP IP at least. It's just not how it works, and it's unreliable, but it really greatly reduces the complexity of my application. So we're going to use an open-ended buffer with this example. The first thing that you should know is when you're creating your buffer, you want to keep the fixed size properties of the buffer at the start of the buffer to greatly reduce the complexity of your logic. So I've got my fixed size properties. There's 3 properties in the object that I'm sending through the network. This is the person object, and the first property of the person is a boolean, and it denotes whether or not the person is male. And this boolean is 1 byte in length. And the second property is the age, and the age is 4 bytes in length and is a 32-bit integer. And the second property is a various lengths, and it's a string, and that denotes the name of the person. So when I'm creating my buffer, the first thing that I'm going to put in the buffer is the male property, and that's going to be 1 byte in length, and it's pretty straightforward, and it's going to be placed at the 0 index of the buffer. After that, I'm going to put my age in there, and the age is going to be placed at 1 offset in the byte array, and it's going to be 4 bytes length, or 4 bytes long. So the next property is going to be placed at the length of the age and the length of the boolean here combined, which will be 5 bytes, and ultimately result in 5 elements into the byte array. So when I'm placing my name, it's going to be placed at offset 5, and then it's just going to be open-ended. It's going to be various lengths, and you can calculate the total length of the buffer here by adding the bool, which is 1, and the age, which is 5, and then the length of the string. So it's just pretty much 6 plus the string length. And let's take a look at the person object that I've created. Okay, so here are my 3 properties: name, age, and male. And then I've got a default constructor, so you can construct the object normally by setting the properties after construction. And then I've got this special constructor here that accepts byte data, and it takes the byte data and it converts it to object data. So the first thing that I'm going to talk about before I get into the constructor is the 2-byte array method. And this is pretty obvious. It converts the current instance of the object to a byte array so that you can send it through the network. Okay, so what I've done is I'm using a byte list, and this abstracts you from using the indexes and whatnot. I just prefer to do it this way. So the first thing that I'm going to do is I'm going to start adding things to the byte list, and I'm using the bit converter class to convert the boolean here to a byte array, and that byte array is going to be added using the add range method of the list class. And I'm going to do the same thing for the age. It's recommended to use the encoding class to get the byte array or the byte data of a string, and opposed to using the bit converter class, just because it's more specific to the string and a bit more reliable. After that, I'm just returning the list to an array, so just converting it all to an array. Okay, so let's take a look at the constructor. I'm assigning to the male property here, and I'm using the bit converter class and a toBoolean method, and I'm passing in the entire buffer that's passed into the constructor, and I'm specifying the index is 0, or the start index, sorry. And you don't need to pass in the length of the boolean, because the method is aware of the length of a boolean. It's always going to be 1. And after that, I'm doing the same thing for the age, but it's going to be placed in the buffer, or sorry, it's going to be retrieved from the buffer at index 1, and it is aware of the length of the age because it's going to be 4 bytes long, which is also 32 bits long. So I'm using the toInt32 method. Then after that, I'm using the encoding class to get the string. So I'm passing in the buffer, and then I'm going to specify the index, which is 5, which is the combination of the previous elements of the buffer. And then I'm going to specify the total count, or the total amounts of data to be copied. And then with the string, since it's of various length, you need to specify the length of the string. And the length of the string is going to be the total buffer length minus the last two elements length, which will be data.length take away 5. Okay, so I'm going to connect to myself, and I'm going to type in my name. That's not my name. And I'm going to type in my age, and then I'm going to specify that I am a man guy. And I'm going to connect to the host, and I think I'm already connected, so I'm going to hit send, and all of my data has been sent. So my name is Brazon, and I'm 20, and I'm a man guy. So with the TCP IP servers, you have 3 options. You can use threads directly, or you can use the built-in asynchronous methods, or you can use a background worker. And I'm using a background worker because I'm just more familiar with it than anything else. And that's how it's going to be checking for connections and then checking for data. And this will be on my samples page on my website if you want to take a look at it.